Welcome, everybody, to episode 4 of Fill the Glass. I'm Kerry Millsap. And before we get going, I want to take a minute to honor someone who's had a tremendous influence in my life. Jimmy Harkey, James R. Harkey Jr., is the Mr. Harkey in the blog post and in the first chapter of this book. He taught college algebra in high school, and trigonometry and analytic geometry and calculus. And Mr. Harkey is largely responsible for anything good about how I think, how I work through problems. And his axiomatic approach, where you basically are very clear about the rules, you learn the rules, and then you play the game of, trigonometric identities or differentiation, whatever the task of the day was. Mr. Harkey taught us how understanding the rules of the system was really, really important. I've written several times about his influence, and if you'd like to see probably the one that sums it up the best, one of my blog posts from 2011 is this axiomatic approach to algebra and other .html. You can hit it with the QR code, or you can go to kerrymillsap.blogspot.com and just search for the word Harkey. But Mr. Harkey was 94. He passed away peacefully at home last Thursday. And he led a remarkable life, and I'm grateful that he was a part of it. So let me move forward from that and introduce today's awesome guest. Really, she's officially now the first guest on Fill the Glass. You've heard her voice before, but Nancy Spafford is a database administrator and other things. I'll get to the bottom of this in a minute at National Ignition Facility at Lawrence Livermore National Laboratory in Livermore, California. And Nancy and I met, I guess we were both about 12, because we've known each other for many decades, but we're not that old. So that's the only way the math works out, is we had to have been 12 when we met. Let's see, I met her, I guess, in the 1990s when I was a consultant at Oracle. I met you and Andy Rivenis and Neil at the same time. And I took a tour of your facility, and it was mind-blowing. And since then, we've been in contact pretty much the whole time. So Nancy, good morning. How are you today?
Very good. Thank you, Kerry.
Excellent.
Morning, everybody.
Now, the National Ignition Facility, the NIF, has been prominent in the news lately. Like I said, I've taken a tour of the lab a couple times, once in person, maybe twice in person, and once virtually. And it's absolutely mind-blowing. So Nancy, please tell everybody what your role at NIF is.
Okay. Well, first of all, before I didn't tell you this, Kerry, I forgot. This is the Ignition t-shirt, because on December 5th of last year, we achieved ignition. So I wanted to wear that today in honor of our accomplishment. And so first of all, my condolences on the loss of Mr. Harkey. I know how much he meant to you. So I lead a team of Oracle database administrators. I'm the lead for the database team at NIF, and we do Oracle, MS SQL, and MySQL. It's just, we do a lot of support for the National Ignition Facility. Their primary goal, their primary product is data, and it's mostly data in Oracle databases. And that's what we take care of. That's our care and feeding. That's our responsibility.
So there was a project, I think the most recent thing that we've done together was probably 2 years ago, maybe 3. And there was a scientist on your team that was, if I remember the story correctly, I'll have you tell it in detail, but I think I remember there being a scientist who wanted to do more experiments per day, but really couldn't because there was a slow query that was kind of gating him from doing an experiment to being able to interpret the results. And so I know we helped your team a little bit with that. What was that story?
So this scientist would review the temperature data that was from a diagnostic called Dante. It measures, like Dante's Inferno, it measures temperature. And he would review this data to assess the quality of the automated analysis of that information. And he would look at review shots, the Dante data for shots for daily, for a number of shots. And when I say a number, I mean historically. So he's looking at this dashboard and bringing up this dashboard, which took anywhere from, sometimes it would perform okay. By okay, I mean less than 5 seconds. And other times it would be 1 to 2 minutes long. And we did, you and me and Jeff, we did some analysis, and turned out we found that there were 2 hash plans, and one plan was milliseconds in performance, and the other plan was the 1 to 2 minute plan. And so you guys wrote a test harness. I was reviewing some of this over the course of prepping for this day today. And you guys wrote a test harness that allowed us to run the query to determine which hash plan it executed using and how long it took. And the primary plan was the poorly performing one. And this scientist was so excited to try to get his data. You can imagine what it was like waiting 1 to 2 minutes for every panel, for every shot. So he was extremely frustrated. And this had been going on for a while. I think we looked at it, we being my team looked at it, didn't come up with much until we worked with you guys. And you guys did the deep dive into the analysis, and we got it by creating a profile and changing the force matching signature to true. So that, because as I recall, one of the challenges with this is that the SQL ID changed almost every time because they were using literals.
Right.
So yeah, so we couldn't just easily make a profile. We had to kind of hack it, if you will, which isn't really a hack, but it was kind of cool. So we did the force matching to true. And to this day, that dashboard works and comes up milliseconds.
Awesome.
So yeah.
Yeah. And I can remember walking around, this must have been 10 plus years ago, and seeing these railroad freight cars, these huge trains. And the tour guide pointed at them and said, basically, that's a capacitor right there. We're going to dump the entire energy of that train car. And by the way, there's 26 others or something like that. And they're going to dump all their energy in this big laser beam array that's just going to compress this thing into basically a nuclear explosion.
A star.
Tell me more.
So we take 192 beams that start at 1 omega laser light. And that's, I think it's a red color, if I'm not mistaken. And we funnel them through tunnels. And in one particular area that's about the size of 3 football fields, we trap the laser, and we use flash lamps that are charged. That's what you're talking about, the flash lamps that are charged with energy, and they flash at glass that is coated in neodymium. And the neodymium captures the energy from the light, from those flash lamps. And the laser is transported back and forth 4 times to energize the light.
It's basically amplified during those.
Right, it amplifies it, exactly. Right. And then the 192 beams are then funneled once again toward the target chamber. And the target chamber that's basically, so I don't know, can you guys see my mouse? You can't see my mouse. I'm just looking to see. So those red areas, those are final optic assemblies where the lasers come down into. And those final optic assemblies will transform the light from 1 omega to 2 omega to 3 omega that then ultimately hits the tiny BB pellet. And it's a billionth of a second. where all of this energy is compressed, and there's X-rays that get created as a result of that compression that further compress this thing.
Uh-huh.
And on December 5th, we injected, I believe it was 2.15 megajoules, and created 3.05 megajoules, I believe, were the numbers. So we created energy, and that's.
And you promised me that when you've got a fusion reactor that's the size of a Coke can that can power my entire city, you're going to send me the first one, right?
Yes, I will. Yeah. So,
God.
right now the challenge for the scientists is repetitive. They want to be able to repeat this, obviously.
Mm-hmm.
And one of the big challenges for this particular type of laser, because there's other lasers and people all over the world doing things with magnetic fusion, and CERN does things with collision, molecular collision. We use optics. The optics, they get damaged, they sustain damage. So the health of the optics in the laser facility, and there's some 60,000 optics, is key to being able to do this again and again and again in such a way that it's affordable and repetitive and doable, I guess, for lack of any other thing. And that data set, that optics data set, my team takes care of. And in fact, you see the jobs.llnl.gov URL there. I have a position on my team looking for an Oracle Application Express developer. If anybody's interested, you have to have lots of database knowledge, because this optics information is incredibly complex. And we keep history so that they can do machine learning and trend analysis on mitigations, that's defects in the optics, and how they're going to be growing. And they want to be able to project growth of these. And we have a new diagnostic, I guess it's a diagnostic for optics damage. It's a telescope, basically, a microscope rather, that gathers this defect information anywhere as small as 10 microns, I believe. And prior to that, the optics diagnostic that would look at it could only see things that were 50 microns or bigger. So we're identifying defects smaller so we can mitigate them sooner and extend the life of the optic on NIF.
So I can't remember. I vaguely remember the schema, about the optic stuff, but what does the repair entail? Is it a replacement, or is it actually physically go and do something to the existing optic to improve its capability?
They actually, if I'm not mistaken, what I think they do is kind of melt it to kind of smooth out the defect.
I see.
Yeah, and I would imagine it depends on the type of optic as well, whether that they actually shave it or what.
In high school, I learned that glass is a fluid, not a liquid, but a fluid. And if you just leave a piece of glass sitting there for millennia, it'll eventually melt down like a bad pair of socks. And so I guess a material with a property like that is susceptible to deforming, even if you just touch it.
Right. And you can imagine putting, amplified laser light through it multiple times. So, yeah.
Well, I can hear in your voice and see in your body language it's exciting, but I mean, what is it like to be part of scientific history? I mean, this really is scientific history.
I'm just so, it's hard for me to curtail the enthusiasm that I feel for this team and being able to support this effort that could eventually, I know the goal is in 10 years and all that, but that could eventually change life as we know it because of a clean energy source. And that just, when I saw the scientists, when they were being interviewed after the ignition, I believe it was Tammy Ma, who leads our inertial energy fusion campaign, who said that she actually cried when they told her that they attained ignition. Because I can imagine it's just so long they've been working on this that all of a sudden, wow, and I just think it's such a cool thing to be able to be a part of this. And my standard line is, well, it sure beats supporting general ledger. Sorry, no offense to anybody, but not that I understand the science or the physics, but you know what you do over the course of years, you start to understand some of this stuff, on a general high level. So it is very cool.
That's awesome. That's awesome. Well, so most recently, it seems like most of my relationships, I was talking to Martin before the call, thanking him for last week. And it seems like most of my relationships with people are people that are willing and able to help me. And I'm really, really grateful for that. You've put in, I don't know how many hours helping me make this thing ready to go. And it almost is. I have another reviewer, Rich Soul, who's sent me a lot of feedback over the weekend. So I've got another pass to go through, but tell me a little bit about the experience of going through that material over and over and over.
So first, I want to say that I think people are willing to help you, Carrie, because we believe in what you do and we appreciate the knowledge. And it's not just your knowledge, that you share it, and you share it so well. So given that, I was happy to read this book and learn as much as I could. And I have to say, initially, I was thinking, how much can you write about how to trace in Oracle? But as we started going through the book, and I had questions, and you would explain things that then generated more questions, I started to realize there was a lot of good information and useful information that could be explained and disseminated among people. One of the things I took away from this book, which I never thought of before, and I don't know why, was testing your trace strategy. Hello? I mean, how many other things do? We test in offline environments. It never once dawned on me to do that. And I thought that was key, because that helps me instill in my users that this isn't going to hurt your system. It will not. I've tested it. And if anything, we learn about your system and can help you make it better.
Yeah.
So it's been a great privilege to be able to read this. And each time I go through it, I learn, and I've been using it on a daily basis, because we have instances where people say, why does this run like this? Or the classic example with the scientist, sometimes it runs pretty good, other times it doesn't. Why? So, and all I can do is educate them on how to instrument their code so that we can trace more easily.
What do you do specifically to that point? What kinds of things do you recommend to your developers and other DBAs when you say instrument your code?
Well, first of all, in the past, I've recommended the ILO subroutine that you had given. I've often given them the sample of the JDBC attributes that you had put in the MOTD book, so that they have samples. They know how to set the attributes.
Okay.
And I do also tell them that they have to unset the attributes, because we've seen that where some other PL SQL code or whatever will have these attributes attributed to them that have nothing to do with them. So I make sure to tell them to unset their attributes.
So let me make sure. Let me just read it back to you. So on a timeline, you've got a function that runs from here to here. And then, so at this point in time, you set module and action, maybe client ID, to certain values. And then that business function ends here, but stays connected and runs other stuff from here on. And you're talking about the importance to reset module and action to be not reflective of the name of this thing, because this thing stopped running at this point. but stay connected. And we see that all the time where people are like, why does this thing takes so much of our time? When you're looking at OEM, for example, and all the pie charts are blue with this name of this thing from here to here, but you know that this thing didn't run as much as it looks like. Well,
but yeah, we saw that, and especially with connection pooling, you will see that because the connection gets reused and it's something totally different
forever.
So yeah.
Good. Yeah. How, this is a product question. You've been using MethodR Workbench since before it was Workbench, back when it was only just a profiler. Have you gotten to use any of the cropping tools or any of the specifically connection pooling type stuff?
Not at this point. In fact, I have a project coming up. You mentioned when we were talking about the optics data earlier, you mentioned you kind of remembered the schema, and you and Jeff had looked at tuning some of the optics queries. And one of the things I remember Jeff saying was, well, do you need to look at all this data? And unfortunately, we do. So as a result, we're looking at these again, and I want to try to use in memory. And I'm working with Andy Rivness, actually, and we're tracing, and I'm going to send him profiles, and I'm hoping to get into the concepts of the oceans, islands, and rivers so that I can get better at that.
Well, that's awesome. Well, you know where to come when you need help, because you've helped me so much. I owe you. I
appreciate it.
Yeah, thanks. Happy to help. Well, Nancy, thank you so much. It's one more thing you've done for me being a guest here. It was really fun listening to the story of what's going on around you there in Livermore, and I look forward to seeing what happens next. I'll stay posted on the physics news.
And I'll be on the Slack channel, and I appreciate all you guys. I know Martin has commented on some stuff that I've asked about before and things. So I really appreciate being a part of this community.
Yeah, thank you. Thank you for mentioning that, because I feel exactly the same way. I think getting this bunch of people together is valuable. It really is. Well, that's it. That's episode 4, folks. Thanks for joining us. I will see you next week. I'm going to try to get David Frankel back on. We'll see if his IT department's opened up his Zoom access. So we'll see. Stay tuned. Let me actually show the last slide here in my set of slides. If you're watching this on YouTube and don't realize it, you can get notified of upcoming events like this Fill the Glass episode coming up next Tuesday at methodr.com/subscribe. That's it for today. I'll see you guys next time. Bye-bye.